Cool. All right. Hello, hello. All right, that was a little bit gnarly. We all good?
Testing, testing.
Hello, hello.
Sounds better.
Are we good?
Okay.
All right. Perfect. Hello, hello. Good afternoon. Technically, I suppose. Yeah, it's 12:30. My name is Alexander. This is Jordan. You can introduce yourself. Anyway, we used to be called Soulbound Labs. We're co-founders. However, we had to rebrand. We accidentally committed trademark infringement, and so now we are Spyglass Labs. So if you're wondering why it says Soulbound Labs in the talk, and here it says Spyglass Labs, that's why. So the title of this talk today and workshop, I suppose, is called Substreams Demystified. But first, let's further answer who we are. So like I said, my name is Alexander Gusev. I'm a co-founder of Spyglass Labs. I'm also a Biddle contributor, and I'm also a former D1 swimmer. I was a swimmer for 16 years and swam competitively at Arizona State University under Michael Phelps' coach, Bob Bowman, before I dropped out of college to do this full time. So it's a lot of fun. I really enjoy it.
All right. I'm Jordan. I convinced Goose to drop out of college, and it's my claim to fame so far. And I've been doing product for 10 years, a lot of consulting, a lot of startup stuff. Got the Web3 bug about 3 years back and haven't looked back.
Hell yeah. So yeah, a couple like prerequisites for this talk, so everyone is kind of like aware. It's not very many. So I assume everyone who's watching this has some like general Web3 knowledge. And then you guys should be familiar with like some programming, not some programming terms, but it'll be pretty abstract for the most part until we start like diving into the code later on. But I would just like to make a disclaimer here because I'm going to say some words that might be perceived as negative. I heart the graph. I love the graph. The graph's awesome. But yeah, I'm also going to give an honest look at some of the developer experience because I feel like it's important to provide context for how far things have come and how much better things are now, and how bright the future is. So none of my gripes are with the graph protocol at all. It's just with particular language choice, and the future is very, very cool. So now that's out of the way so no one gets mad. There's a couple takeaways I want you guys to have by the end of this talk and by the end of this workshop. You guys should know, what are substreams? Hopefully this question will get answered for everyone. You guys should know why substreams are so epic, because they are very cool. How to build a substream, as well as realizing that decentralized APIs have reached a sort of tipping point where now I believe they have reached supremacy over the traditional centralized APIs that we're all normally used to using. And so you guys will see why in a little bit. But before I start like talking about why substreams are so cool or why it's important to use them and why you should use them, let's like establish a problem statement. So like, what is the issue? Why should I be up here talking about some solution without giving a problem? So blockchains are open and anyone can query a node, anyone can run a node, and all your data is there. However, digesting raw blockchain data for something, let's say for a front-end application or even for your own interest, it's pretty hard and complicated to do, especially if you're trying to do complex things. And so I'll give an example. So Bob wants to build an app which shows all the NFTs the user owns. Bob has some options to do so. So he can run a full node and query the chain directly for the event logs, which is kind of like awkward and not the nicest. He can use a centralized provider such as Alchemy or Infura or any of these other companies. He can also use a centralized data indexing service, something like Dune, to do a similar sort of thing. Or he can use a decentralized API such as the Graphs network. And so let's like dive into some of these. So centralized providers. Who here, like show of hands, has ever used Infura or Alchemy or like any of these things? Okay, cool. So most of you guys. Just for those of you guys who aren't up to date, blockchains run on nodes, and so centralized providers are people who run nodes as a service, and they charge you to use them. They also have some nice benefits as like APIs to do things that you'll need to do pretty often, and so they're very easy to use. They're pretty cheap. But anyway, this is what a central provider is. So yeah, companies like Confura and Alchemy provide traditional APIs to do normal stuff that nodes can do, but also more complex stuff. So they make your life easier when you're building your own app or dashboard. Examples include get all the NFTs a user's own, get token balances for a user, and similar sorts of things. So the pros of this solution is it's easy to use and it's cheap. Those are two really good solutions, or two really good pros. Cons are it's opaque. We don't actually know what's going on under the hood or how they're getting this data. Is there any sort of weird manipulation there? Most of the time, this isn't really an issue, like a super severe issue, except in certain cases it can be. They can't be customized. So if you have some specific use case for what you're working with, you're not going to be able to make it do exactly what you want because you're just using somebody else's existing API. It's centralized. That's a really big issue. And I think this is actually a pretty big issue in general for crypto as a whole, because these big centralized providers could definitely become the next AWS or Google Cloud, where we have 90% of all our stuff running through 3 companies that control everything. And I think that's in general something that we all are trying to avoid in this space is centralization. So then another issue is that there's no guarantee for the correctness of data. You're just querying an endpoint. You don't know whether or not they're giving you bad data, whether or not it's maliciously bad, or just like their code isn't working right. So it just sends you some false data, which can also be very bad. So now that we kind of know one solution, which is like with centralized providers, let's talk about some more customizable providers. So there's companies such as Dune Analytics. They provide an SQL interface over a large database of blockchain data so that you can query and share your queries for, as well as like build dashboards. They have some special DSL tool for using for like building dashboards. And so like this is kind of very similar to centralized providers in the way that it's a centralized entity who's serving you data over an API. But the difference is you get to kind of customize what this API is sending out and what you can do with this data. So like you can do really cool things such as getting price history for an NFT within some certain params. Like you can get pretty complex with it. So the pros are it's very configurable. So you can do some really complex SQL queries to get exactly what you're looking for. And then also they have this really cool feature, which is that users can fork existing dashboards. So like, let's say somebody's making a Uniswap V3 tracker and you're like, oh, this is cool. I want to make a fork to do, I guess Uniswap V3 isn't able to be like used publicly. Let's say a Uniswap V2 tracker and you want to fork it over to use Binance Smart Chain to go track PancakeSwap or something. You can fork people's dashboards and change stuff, which is really cool because you don't have to rewrite everything. Some cons are it's more expensive than the centralized providers. It's because they're doing a much more complicated service, so their price should be higher, right? That makes sense. It's more complicated to build and process data. SQL is like not very nice to work with, for really complex stuff, in my personal opinion. That brings us to a third con, which is SQL. I don't really like working with it. Some people do, but generally speaking, I prefer not to touch it. It's also centralized, which is, again, another issue that we're trying to avoid. And it has the same issue. We don't have guarantees over correctness of data. That brings us to the third, which is kind of like the Goldilocks option here. So decentralized API services are decentralized networks of blockchain indexers. And so there's a couple different protocols. The one I'm most familiar with and what I use is the Graph. So they offer decentralized ways to allow users to define custom APIs for blockchain data and then query the network for this data. And the difference with the Graph and the centralized options is that there's like actual financial penalties at stake for serving incorrect data. So there's a whole dispute mechanism. And as a result, the Graph's data availability as well as data correctness is extraordinarily high when compared to other sorts of things. And so yeah, we get like the customization of services like Dune, although we don't actually have to work with SQL, but we get all the data correctness that's even good enough to use back on chain. Me and Jordan used to work on something like this. So previously our company was Soulbound Labs, and we actually wrote a subgraph bridge to enable users to put their queries back on chain, leveraging the whole crypto economic security of the graph because it is extraordinary. Extremely secure. That sounds all great. It's a lot better. Yeah, it all sounds super good, but it's a lot better now, and it will be a lot better in the future. It's continuing to get brighter. Let's talk a little bit about traditional subgraph development. And again, just a show of hands, who all has written a subgraph? Uhal has like done a complex subgraph, like something like a little bit more complicated than indexing raw events. Okay. So the next portion of my talk is called the dark ages of decentralized APIs. Subgraphs at their core are just mappings over blockchain data. So we have our raw data, and when it's being transformed in some way or another, which then is being shoved into a Postgres database. And so the subgraph is just raw blockchain data processed in some way, shoved into a database. And up until recently, this language or these mappings were written in something called assembly script. And assembly script is certainly a language. Assembly script. This language is so many things. It's not a bad language by any stretch, but it's frankly unfinished. And in a couple of years, it'll probably be super good. But why is it painful to use? Assembly script is trying to be TypeScript that compiles to WASM, but unfortunately, it isn't there yet. It's kind of unfinished. And as a result, the subgraph development experience is very painful. If you're trying to use a language feature in TypeScript that doesn't exist in assembly script, sometimes you'll get a helpful error message, and then sometimes you won't get an error message at all. And basically what it'll say is it will say, we don't know what you broke, but you should just start deleting lines of code until you delete something that broke our code. So that way you can know what's up. And yeah, I don't know about you, but that is an insane compiler error to have in a production language in which we're supposed to be building really cool stuff on. And people have built really cool stuff on it in spite of it, but it's not because of this. And so as a result, it's super painful to use. And so here's actual production code that I wrote to get around this lack of features in assembly script. This was to get around the fact that assembly script doesn't support generic fixed size arrays. So in the code I was working on, I had an array of arrays that were supposed to be too long. I could not do this. And so what I had to do was I had to write a custom class called tuple, which took two generics, and it looks like this. And working with it was an absolute nightmare. And it was just silly. Like, bro, I just want to index my data. I don't want to have to, get around this compiler stuff. But there is a silver lining in all of this complaining, and that is that after this pain is done and after a subgraph is built, it is the single best API experience I have ever worked with. And so the graph makes it super easy to get the data you care about and use it in a super easy way. Oh, and it's decentralized and secure because you have all those really good guarantees that I was talking about earlier. So like this is an example query of how we might get a user for a specific address, get all their NFTs that they own, and get their IDs, names, and descriptions or something. And like that's awesome. Building front ends or building any application with GraphQL is just very enjoyable compared to working with anything else. So circling back to subgraphs, the pros are that, or I guess decentralized APIs, are that they're highly configurable. They're also the cheapest option per query that you work with because of the decentralized nature. Indexers can charge different fees, and so you can have an open market for competition so people can get very low fees or have unoptimized stuff and have high fees. It's also decentralized, and you have extremely high data correctness that you don't have with these other sort of services. The cons are this requires learning an esoteric and unfinished language, which is assembly script. It also requires learning about a brand new and pretty complex protocol, which is the graph. You can't compose subgraphs like you can with like Dune stuff, so you can't leverage someone's existing thing inside your own query. And they're also slow to sync large subgraphs because they use RPC calls under the hood, and it's all linear. So we'll get into this in a little bit. But most of these problems have been solved with Substreams, which is the technology that I'm here to talk about. A crab ushers in a new era. So in case you guys don't know, crab is like the language mascot of Rust, and so the title of this is a nod to Rust being a crab language. Anyway, things weren't looking great for decentralized APIs. The trade-off for having decentralized and secure APIs was a very rough developer experience with, frankly, poor performance when compared to its peers. So the syncing time was very slow. It took a long time to do everything, and it was just painful. But then about a year ago, Substreams was born, a new method for indexing blockchain data that was built for parallel processing in a streaming fashion, written by Rust by some super cool people at StreamingFast, which is a core dev team for the graph. And these guys really did a lot of incredible work, and we'll see why here shortly. So Substreams brought with it composability, modularity, and insane speed increases for data indexing. So upwards of 50 to 100x in certain cases. And so to put in perspective, 50 to 100x, I'm going to give an example because that sounds like, oh, that's a lot, but it's actually a ludicrous speed up. So let's see why they're so cool. Speed. Substreams are very fast. To understand how much faster substreams are than subgraphs were at syncing, imagine your commute to work takes 10 minutes. 10 minutes is a reasonably quick amount of time, but if we were to 100x your commute speed, the same commute would only take 6 seconds. And so I don't know about you guys, but like I would way prefer to commute to work for 9 minutes and 54 seconds saved. That would be awesome. So that means that things that were bottlenecked by performance are now super possible leveraging substreams. A good example is the Uniswap v3 subgraph, which because of its structure and how it makes new contracts was very difficult to track. However, it took previously about 3 months to sync, and as a result, no one actually synced it because it wasn't really feasible. But they got it synced in 50 hours, which is very, very huge in terms of like what we're able to do with subgraphs now. And so they're very, very fast. It's awesome. They're also modular. And so substreams work by having little WebAssembly modules that are composed to extract your final data that you're looking for. So let's talk about that a little bit more. There's 3 types of modules in the substreams. This first one, sources, you can kind of say isn't a module, but I consider it that it is a module because it's used as an input. So sources are sorts of the building block of data that you're interested in. So sources are things such as blocks or instance data. So you have an Ethereum block which has a particular structure, and you're going to get data from it a particular way. So this is kind of the root of all substreams. You then have maps. And so maps are a module which take in an input or multiple inputs, and they output something. So they're a lot like a pure function. So they take in some data structure and they output another data structure. And so this is up to you to decide how these work. And then the final type of module is a store. So modules that act as a key value store, they enable you to aggregate values from maps. So maps just transform your data, and stores allow you to do more complex stuff with that. So that's it in terms of the things. Actually, sorry, I forgot about this slide. So yeah, there's a couple benefits that come with this modular structure. So because of the structure and the modules not being able to modify each other's data, we can run these modules in parallel. So because the way it works is you have a source which is then being transformed and doing something, it doesn't matter what order we run these modules in, because as long as it is taking a block as input, it'll spit out the correct data that we're looking for. This also has a benefit of the development process is much easier because all of your possible bugs are isolated to these modules. Like who here has ever done like functional programming in like Haskell or Lisp or something? So one of the reasons, or I guess Elixir is also a very popular one. He's quite partial too. But yeah, one of the reasons functional programming is so nice is because you don't have side effects. So it's much easier to debug than a giant loosely typed thing. So anyway, they're just easier to debug. It's the point of that. But then the next piece that's really cool is that substreams are composable. So because substreams have this modular architecture under the hood, we can import other people's modules and use them out of the box. So this has the benefit of forking from Dune Analytics and stuff like that, because we can leverage people's existing builds to do more complex stuff. So that means that I can build a substream that extends the Uniswap v3 substream without needing to rewrite it myself, which was previously not possible in subgraphs and how we were doing it in assembly script. I just simply import the substreams S package, which is a special data encoding, which represents all the modules and types within a substream. And then I can use all their modules directly. So I can just import it in my file, and then I'm good. I'm off to the races. And so now we talked about it, let's give a quick demo of how substreams work by using Substreams.js. But before I do that, does anyone have any questions or anything they want? Okay, cool. So we're going to go to this link right here. So this is a really cool demo made by someone. Oops. Actually, yes, Sebastian. And this is a way to use substreams within, just going to get over here. So this is a way to use substreams in the browser. So we can drag and drop a substreams S package. Oops. we can drag and drop a S package, and we can start working with it. So here I have the Uniswap v3 substream, and we can see that when I import the S package, we have all of these different things. So these are all the modules that are within the substream. And so let's say I want to start streaming, map pools created, which is going to output some protobuf every time a pool is created. I can just click stream, and if the internet is good, yeah, like all this data starts streaming in. And so you can see what this looks like. So pools is an array, and it has all these different fields. So we have an address, which is a string, that's the address. There's a timestamp created at. It has another protobuf for the token that was created. This is a DAI and FEI USD pool that was created. I don't know what that is, but anyway, you can see how quick and easy they are to work with. This would not be possible with Subgraphs back in the day, but it's a pretty huge shift. So now heading back over here, let's move on to the next one. Let's build a simple substream together, shall we? So we're going to do something which is kind of cool that wasn't really possible before. So let's do this one. So I wrote this subgraph or substream. You might have seen, I think it was posted on some graph cord, or some graph developer thing. But the purpose of this substream was to test how fast and how crazy we could go with data indexing. And so the idea I had was, I was like, okay, like what's something that has a bunch of entities that would be kind of cool to track that like we couldn't do with subgraphs before. And so that was, okay, let's just track every contract that was ever deployed to Ethereum. So this requires us to go through every single call that ever happened and do something with that. So this wouldn't be possible in subgraphs, but it is super possible here. So we define this function called map contract, which takes in an Ethereum block as an input. And what we're going to do here is we're just going to take the block. We're going to look at each of these transactions. And for each transaction, we're going to look at each of its calls that it's making. And if the call type is 5, which means that contract is being made, we're going to spit out a contract created here. And that's it. It's a pretty simple module. It describes what it's doing, pretty straightforward. And then we return a special struct, which contains all the data that we're looking for. And so we can pop this open and actually try it. That's like way too small, right? Let's make it bigger. Okay. So yeah, to just give an example of what it's like to run something like this, I just ran SFP, which did some authentication stuff in the background, but we can just go substreams run contract, and we can just start streaming and see what kind of stuff that we find. So it will start streaming here, and these are contracts that are being mapped, that are being created. So this contract was created at block number 17,572,000, whatever that was. So that's kind of like how you run substreams. And we can also talk about this real quick. 1 sec, bear with me. All right. Substreams in general is a super polished experience to work with. So you can see how simple that code was up there. It was only a couple lines of code. Oops. Anyway, so yeah, it was only a couple lines of code to work with to do something pretty complex, map every subgraph. But we have some really nice tools. So they have some really cool stuff like the Substreams GUI. The Substreams GUI allows us to do very similar sorts of things, except the difference is we get a nice little GUI. So let me authenticate, try again. And so we can see how the syncing goes, and we can like kind of visually see what's going on. So like, again, the thing you should be taking away is Substreams have a super nice developer experience when we're working with them. So now that I guess let's also talk a little bit more, because there is a little bit more than just this code here. So this code defines how our code should work, but we do have a configuration file that we can talk about. So here is the configuration for our substreams. So we import this entity package, which is important for building an actual subgraph that actually we won't talk about right now. We import these protobuf files, which define how our things look, like how the structure of our data should be. So we have a contracts message as well as a contract message, which contains an address and a timestamp. And we're all just importing these so we can work with it. We import the compiled WASM binary from our code that we wrote, and then we define some modules. So these modules are how we can use these S packages, in other substreams as well as inside of the browser if you want to do stuff like that. So we just define what the module is, what kind of module it is. So it can be a map or it can be a store. Its inputs. So this one has a source input of an Ethereum block, and it has an output, which is our contract type that we made. So if we go back to test.proto, we can see it's exporting this contracts type. And so that's really just about it as far as what's required to build a substream. And so does that make sense to everyone so far? Does anyone have any questions? Yeah. No, yeah, so all this code, so this is Rust code, and so when I actually want to work with it, I'm going to run cargo build, and yes. Yeah, so the Substreams YAML file is kind of like an interface, and then we simply define what modules are present, but then we actually have to put it over a binary. So that's kind of what we're doing right here, is we're saying, hey, the binary that we're working with here is going to be the compiled output of this directory that we're working in. Any other questions? Anything? Cool. And so now you guys are Substreams experts. Let's look at a not so simple substream. So let's go look at the Uniswap v3 substream here, which we can go to their README. Sorry, whoops. Forgot to actually add this one here. We can go to the README or something. So this is going to be a little bit wild because this is a really complex substream. So there's a lot going on here because, I mean, a lot is relative. Doing this in assembly script land would be pretty gnarly. But how the hell are we supposed to understand what is going on at a glance? Well, the good news is Substreams, again, has a really good developer experience, and so they have a command for this. So within the Substreams CLI, they have the Substreams graph command, which I find super useful. And what we'll see here is we get this link. And so if we click on this link, we get a full-blown visual representation of how all the modules are composed. And so this is auto-generated. This was just defined from the YAML file. So that file we were just working at, this one, defines all the different modules and how they're all connected to each other. And so we can visually see it. So we can say, OK, so there's an Ethereum input block, and then this feeds its data into the mapping pools created, and then it also feeds its data into map extract data types, which outputs data into the store native amounts. And eventually, it all goes into this final output module of graph out, which is how we actually sync it into a subgraph. And so this is really, really powerful because I've worked on complex subgraphs and I've worked on, I've worked on complex subgraphs, and grokking what's going on in a large code base is really gnarly. And so having the tools to be able to understand what's going on and at a glance be able to understand, okay, so I'm looking for this particular piece of information from this substream, or I'm looking to modify this particular function. I can just look at this visual representation, and it's like, wow, okay, cool. So I want to change the map pools created function. And so again, the developer experience is so good compared to any of the competition right now. And I'm very excited about it because I've spent a lot of time doing this sort of stuff. So yeah, I'm not sure if there's anything else really that I want to show off from that specifically. I'm not sure anything else is super huge. But this brings us to a very special piece of information that I was hiding, and hiding from you guys. Not really, but map modules have a very special param, which I think is the killer feature of Substreams. And this is the thing that makes me make such a bold claim, which is that decentralized APIs have had or are now superior to our centralized alternatives. So map modules can have an input type of param. And so what does that mean? This is a string which we can use and customize at runtime. So our maps are kind of like functions, and they take input of some data, whether it's a block or another map module, or in addition to, which is normally how we use it, we can take in a param string. And so this is just a string. We can do whatever we want with strings. And this really unlocks some crazy things. So let's take a look at how we're using these modules with params to build a very powerful plugin system with Spyglass, or for Spyglass. So if we pop over here to the modules, who here has ever eaten a hot dog? Because I need to explain what the hell a hot dog is, because it'll make sense here. Okay, I assume everyone has eaten a hot dog. So we had a problem when we were building out this plugin system, which is we really like this idea of modules with params, and so we were like, all right, they still need to have protobufs defined as inputs and protobufs defined as outputs. And so we're like, if we wanted to make a really dynamic system, we're going to have to build a dynamic typing system into protobufs. And so hot dogs are effectively that. The reason why we named it hot dogs is you know what a hot dog looks like. You can eat a hot dog. You can also eat a hot dog without really knowing what's inside. Like, is it, beef? Is it possum? Like, you don't really know, right? And so it's only when you bite into the hot dog that you'll see what it has inside. So all of these modules take hot dogs as inputs and give hot dogs as outputs. And so this allows us to do some really flexible stuff at runtime. And so in all the demos I'm about to give you, just know no code is being changed. There is no compilation happening behind the scenes. This is all configured at runtime. And so let's do a really cool example. So I have this little script here. Let's go here. Let me just comment this out real quick. And what we're going to do here is this is a little script I had to give this demo easier. It's just some shell scripting. And so we have a special module here called map events. And the way this works is it takes in a param string. And the way that we are parsing this string is we have an address, which is separated by 2 ampersands for a contract ABI. Does everyone know what a contract ABI is? So why that's so cool is that because we're in Rust and we can just compile the WASM, I can use an existing Ethereum ABI decoder to get all the events, get the topics that they should be in, and dynamically, by just passing in an address and its ABI, is I can write a generalized module which allows me to index any events that a contract is emitting. And that's crazy to do at runtime. That's actually so powerful, because the alternative to doing this was previously building a whole node substream, or maybe building a custom Dune API or using someone's custom API. But here, this is all done at runtime. And so I'll give a demo here. I will stream the blur contracts. And let's see. I just want to make sure I'm not running this. I don't want to filter events. Map events. And then I'm going to run this. Not the talk. Sorry, I need this one. All right, so we're going to ./run.sh to run this. And what this will do is you can see all this data is streaming in. It's crazy. It's wild. These are blur transactions that are filtered to be either Milady trades or Bored Ape Yacht Club. Actually, wait, sorry. No, I lied. These are just blur trade events. And using this exact same module, we can also just change this out to instead, let's say I want to track Bored Ape Yacht Club, and I want to track all these things. I can just modify this, and let's say I actually want to filter these events. I'm just going to filter events. And we can now, within this exact same module, stream only Bored Ape Yacht Club transfer events. And so what you'll see here is as it streams through, we're going to have some transfers pop up, and we can see here that this is a transfer. It's of type hot dog, and it contains all these different keys, which are our stuff that we're tracking. And this is all done at runtime. It's so cool. It's so cool. I mean, at least I think it's super cool, because I've never seen something this flexible before, and it makes me really excited. And so basically, that means that what we have here is that within a single module, this is all done in one module, technically 2 for the filter events, we are able to stream and process event data from any contract or contracts, because we've tested this, stress testing 12 different contracts, addresses passed in, ABIs, and we can index them all within a single module and output them in hot dogs. And it's great. The hot dog the future will be powered by hot dogs, hopefully. But yeah, so that's kind of why they're so cool, is because we have very flexible dynamic typing that we never had before. Does anyone have any questions? Anyone's mind blown? Anyone picking up like pieces of their brain off the floor? Anything? You 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 don't have to pass that as a param. Substreams has an endpoint, so anything that is running a fire hose capable full node will be able to work with substreams. So you can pass in a custom endpoint for, let's say, mainnet or another chain which supports it, because there's fire hose implementations for quite a few chains, I believe. I think like Optimism has one, a couple other ones. But that, yeah, you can just do that by pointing it at a different endpoint, but it'll still process the data all the same. So the only thing is that the param just has to be defined when you go to run the substream. So you can set it when you're running it for the first time, or like if you want to use this same module but instead track something else, you can just run it with a different input param. Does that answer your question? I'm not sure I fully understand, but it's very flexible. And so we're using all this for some of our stuff. It's enough code, enough backend sort of thing. Let's look at some pretty images. I will hand it off to my wonderful co-founder, Jordan, and he'll show you all the cool stuff that we can do at runtime using these substreams. And it's really cool. I'm passionate about it, so you guys can tell. Any?
So yeah, we've done some wild things with substreams, like indexed every contract in existence. Goose was like, let's try to do it with like 25,000 NFTs and grab all the metadata and pricing information for it.
Yeah, it was 12,000.
12,000, sorry.
NFT marketplace that was being made. They wanted a Substreams powering UI. So we indexed 12,000 unique addresses, able to filter stuff.
You can kind of just throw whatever at it, and usually it just works. Yeah, so I tried to do this with Goose last year with Subgraphs, and I need an HDMI cord. Goose. Oh, there we go. Right now, StreamingFast has benevolently offered their Firehose access for free. So anyone, if they just want the substream, that is 100% free. If they want to deploy a Substream-powered subgraph to the decentralized network, that will cost some GRT and gas fees. And I haven't deployed one recently. Goose,
I mean, gas in general is a lot cheaper right now.
Yeah.
Probably within the realm of to deploy, and that's it's very cheaper than any other option. So definitely
some extra GRT for curation and managing, the whole decentralized network, but it's fairly affordable. Yeah, let's see if we got something going on here. Okay. So has anyone used Dune before? Pretty dashboards. Okay, cool. Charts. Yeah, amazing. Ooh. And we've been hacking till Goose is night shift. I got the day shift. So this is rough around the edges. Things can and will break in demo, even though I just tested right beforehand. But anyway, I'm very good at making things pretty, and we wanted to make a really simple analytics experience for both technical and non-technical users of Web3. Like the status quo right now is go to Dune, and some of these people spend 20, 30, 40 hours writing a single dashboard. It's hundreds of lines of SQL to create detailed charts. With the Substreams module system, which we can kind of compose at runtime and chain together multiple substreams. And these are all open source. We're going to try to make a little plugin system for folks to play around with, download, hack together, whatever. Our goal is to get to do 80% of what Dune can do, but do it in under 2 minutes. So if I grab, say, like the Doodles NFT smart contract, I'll copy that, I'll paste it here. We're gonna load up the contract address, the start block, the events, and the functions. I'm gonna click the sparkles, start building. And here, let's go full screen. We have a visual representation of the smart contract. I'll just kind of like zoom in a little bit on that. Mainnet to Doodles. Doodles, by default, we just show the events. Approval for all. Ownership transferred and transfer. Let's delete that for now, come back to it. Over here, because it is a crypto winter and AI summer, we have GPT-4 powered crypto documentation. This excites the venture capitalists. They're like, wow. So you got to be practical in these days, but we still believe. And down here, I'm also a sucker for animations. So if you click that, it's going to pan zoom to the proper thing. But let's actually talk about how substreams can, like, you saw some of that Rust code, which is a S package, some WASM, that takes runtime params. And it's just going to be, for this particular example, it's going to be the address, which is the Doodle smart contract. It's going to be the ABI for Doodles. And it's also going to be the event in question. Let's say we care about the transfer events from to token ID. I'm going to click visualize, and we get a nice little pop over here. You guys see that of data grid, XBAR, Y-line. Basic, let's do a data grid. And I'm going to say House of Web3 demo. I have some start block and stop block information. I just want to stream a little bit. And let's click create visualization. Okay, we have our visualization, and boom, let's start streaming data. So let's make this a little bit bigger so you can see this. We passed in the ABI, the smart contract, and the event name to the Rust module, and it just spit this back out in about 3 seconds flat. We can extend the block range for more data, but for the sake of the demo, small is better. We can skim, we can sort, and I don't like data grids because I'm more of a visual person. Let's go for a tree map. Okay. Let us not do the size by block number. Let's do the size by token ID. Thank you. Account. And let's do group by token ID as well. By token ID. Count of token ID. And let's just delete you. No order by. Cool. So here we have a visual representation of the transfers of all Doodles. And we hover over and we get to see who's transferring what Doodles in the last 100 blocks. Sunburst, pick your poison. OHLC. This is where it gets really weird, where I'm not a DeFi trader, but we're pretty much any blockchain data we want to be able to visualize in whatever format people want and parse it from Substream. So we are doing that pretty quickly. And this is all possible because instantaneous streaming of runtime modules. And we're very grateful to StreamingFast and The Graph for funding them because we're making good use. If anyone is interested in making their own plugin, if anyone is interested in playing around with substreams, we'll be publishing some open source plugin guides, and folks can do their own thing with this data pretty shortly. But yeah, thank you guys so much. Substreams are awesome, and we hope you guys start playing with them soon. Yay. Questions on product can go to me. Questions on Rust and substreams can go to Goose, or vice versa. Those answers might be confusing. Yeah, come on up here. Now, this guy has been going down the rabbit hole on Rust and substreams for 3 months, doing nothing but how to make this stuff cool. I can also just start doing more stuff here. Let's add super rare bizarre.
So yeah, I guess like another pretty cool thing about all this is that I was showcasing some of the cool code and how cool this all is, but it's really cool because we're able to do complex data analysis in a no-code environment because we are able to make everything so simple, where we just customize some params and then like, oh, there's the data you were looking for. And so I think it's pretty exciting to be working on because I think it solves quite a real problem, which is like blockchain data is very hard to process, and it's like you're drowning in a sea of information. So anywho.
just hit a bug. That was a mistake.
So this can you do extra transform data, or is it just that you're providing the raw data or?
You can indeed. So there's actually a whole way to do virtual columns using this language called ExpressTK. And so you can do pretty advanced computations and derived information from these like kind of more flat generic events. And so, for instance, you can do like frequencies or like average prices that things are trading at. And so you can do all this by just clicking little buttons, which is pretty damn cool.
I'm trying to think of a good transformation on the spot to do here. Token ID.
I don't know.
Like single quotes for token ID? Token ID plus 5?
I don't remember. I don't remember. We haven't played around with this too much, but we're freestyling. Bear with us.
99999. Save that column, and let's just nuke all the other columns for a little bit.
Yeah.
You guys, and let's get Alexi's column
So
up
all
there.
those data fields, getting them from that you define.
Mm-hmm. Yeah, so we're just grabbing, like this is a pretty simple demo because we're just processing event data, but all the fields are just the fields in the event. So we parse the ABI and then we get all the information back, as well as some nice little transaction metadata stuff. So we have like, you know, how much gas was spent, how much like total gas was spent versus gas was like allotted, you know, that sort of thing.
See that over here. Get the raw data from substreams, and I mean manipulate and visualize it and do like extra computations, mainly in the front end. But our hope is that like if folks want to do really complex computations, say they want to like get price, like this is the Doodles smart contract, and they want to get price feeds from Blur or like OpenSea, like that would be a new substream module that could be compatible with our plugin system. So there's like a handoff, and yeah.
Yeah, and but then also I guess to further clarify is that yeah, so GraphQL is used for like subgraphs, and substreams are just the data transformation layer. So we're data transforming here to just dump it into our UI, but there is also a module which supports, you know, hot dogs are supported for this module that I wrote, and it does dump it into a Postgres database with a GraphQL API on top. So you can also do your normal GraphQL requests. This isn't a replacement to that. This is just, yeah, exactly. Yeah. You can also just dump it directly in here. Yep. No, in theory, you can dump it to anything. So one of the unique things about substreams is you can write custom sinks, they're called. So substreams is only concerned with data transformation, and then you are working with this dump of information that you sync into something else. So you can. Mm-hmm. Yeah, I mean, yeah, you can definitely write a custom sync, or we can, or if there's enough need. Yeah, well, maybe I'm not sure I fully understand the question. Are you saying, like, is it possible to sync the substreams output to a different type of database? It is, yeah. But so the way that you, is it supported for the database? No, not for the one you were talking about, but it can be. It's just a matter of writing a wrapper that basically transforms your Postgres, or sorry, not Postgres, your protobuf into whatever database entity you're looking for. So that's like how the Postgres syncs work. That's how the graph output syncs work, is you just have to conform it.
Yeah. Take a look at this page here. We have some syncs available. PostgreSQL Mongo file-based key value. I know people have done like a ClickUp, like sync could be like task manager. And I know, I think Prometheus is a time series based database, and they support that, though there's no docs here, but that is supported. Yeah. The Fire, I remember not this Alex, but the Alex, the CTO of StreamingFast, mentioned in passing the fire hose, because it's public, they had to slow it down a little bit for everyone's consumption. But I imagine if you run your own fire hose node or pay someone to do it, it would be pretty damn real time.
Yeah. It can even operate on stuff like unfinalized blocks. It's super performant.
Does it have memory stuff?
Mm-hmm.
They don't support Polygon probably for that reason right now.
They don't? They do have fork-aware substreams though. Yeah, so it is aware if blocks were rearranged and it knows to sync this.
They support Polygon, I'm dumb.
Okay.
There we go.
Yeah, so I think that basically, I don't really know. This is a guess, so I don't know. Yeah, I mean,
Where that you can use it on purpose to, this is for the form. So it's up to you and me to handle your, it's very important where you have, the possibility of handling those forms in whatever way you want. You can purposely look at them or your reward at your end on your sync and erase the data and produce new reward data and sync. Kind of like the syncs, right? It's like if you open it,
yeah.
you can dump your data in whatever you want. You can do it tomorrow and write a sync for it. Very powerful.
Thanks for the answer.
Should be giving this talk, Alexi.
This is from my indexer experience.
Yeah.
Alexi's
I don't have that.
semiotic AI, and he knows everything damn near to do with databases and blockchain interaction. So pretty good, pretty good. They're the best in the room.
Right.
But yeah, please, substreams.vercel.app is live right now. It's open source. Everyone wants to just throw S package up here and play around with what's it look like to run a substream and get the data out here. This is a fun playground. What other things can we tell you? The Substreams Discord is super responsive. They've got 6 engineers and they all seem to be on call, which is unusual, but kind of cool. And yeah, we can be found right now at twitter.com/Soulbound Labs until I rename this to Spyglass Labs. But if you want to catch us, I've got 400 shirts, and I'm going to give them away to the homeless of Santa Cruz, and then we're going to rebrand to Spyglass, and no more merch. I'm against merch at this point, but there's the story at this point.
So, as well, Blind Nabbler.
Oh yeah, Blind Nabbler. Let's chill. Let's chill. We want to talk. If you guys want to play around with our stuff, I'm not going to ask questions about that. It's at Soulbound Labs until tonight, and it's going to be whatever Spyglass themed Twitter handle I can find. Are you? Oh my! Did you just check that?
Just take that.
Spyglass Pirate Collective. Bingo. Our lawyer has encouraged us to just kind of roll with it and see how lawsuit happy people are. And if they're lawsuit happy, just throw a weird suffix or prefix, and then they can't do anything. But we're gonna. Yeah. Bingo. Yeah. Bingo. Mm-hmm. Golf courses, movies.
Well, that's what we do like in the evenings. After we get done.
the post-work hobby. But yeah, on the UI side, like right now we just got the visualize, and this is once again all powered by one Substream module for every event on any chain, which is cool. This is not live yet. Give us another week or two, but we're thinking just people can write custom modules for, like I said, like let's get pricing data from Uniswap. Let's get like activity from Blur or OpenSea. And it's fair game to take individual WASM modules and just kind of glue them together and see what happens from a visual side, or download your own substream and do it for weird degen DeFi stuff. Yeah. Local host port 3000. Oh yeah, I have it installed. Let's see here. Is it ngrok just localhost port 3000? No flag there? Oh, sorry. Damn. Okay. No tunneling. All right. Thank you. That's it.
Yeah.
Yay. I appreciate all 10 of you.